Dear second prep, our lesson today is operation on interval. We have studied the interval before, so we will complete the operation on intervals. You have to remember the set you have studied before in 5th primary. If we have set of integers, x is 1, 2, 3, y 3 and 4, and the universal set 1, 2, 3, 4, 5, and 6. To represent these sets x, we will draw it in an oval, 1, 2, 3, and y intersecting x at 3. 3 is common element here, so I used 1, 2, 3, 4, so the rest and in the universal set will be 5 and 6. We studied that I have operation called intersection. This operation is the common elements between x and y. It will be 3. The union operation, all elements in x and y, or x or y, it will be 1, 2, 3, 4 without repeating. The difference, which is the number in the first set only, or the number at x, not at y, these numbers will be 1, 2. 1, 2 belongs to x, doesn't belong to y. Y minus x, the same, y not at x, it will be 4. The last operation is the complement, x dash, it is the elements doesn't belong to x or completing x to be the universal set. If x 1, 2, 3, so it will need 4, 5, 6 to be universal set, or the elements here which are doesn't belong to x, it's 4, 5, and 6. Y dash the same, all except y, it will be 1, 2, 5, and 6. This operation we will take it again, but this time we will take the same operation for the new set you studied is the interval set. And you have to remember that all the answers here must be always sets. First, we will study the union and the intersection between two intervals. You have to remember that the union is all elements in the two sets, and the intersection is the common elements in the two sets. For example, if I have x negative 3 and 3, y is negative 1 and 5, we will draw the two intervals at the same straight line. First, we will draw negative 3 to 3, closed negative 3 to closed 3. This is x. And y from negative 1 closed to 5 open. You have to consider the ordering of the number here, negative 1 between negative 3 and the 3, and the 5 which will be after 3, and this is y. First, he wants to find the intersection between x and y. The intersection is the common element, or the elements in the blue and pink together. It will be this area. This is the common element up and down. It will be the numbers from negative 1 to 3, and we will take negative 1 and the 3 as it is. Closed, it will be closed negative 1, closed 3. The union, all the elements in the two intervals as it is from negative 3 closed to open 5. The difference, which is the elements in the first set only. For example, for the same example here, I have x from negative 3 to 3, y from negative 1 to open 5. This is y. And he wants to find the x difference y, or the difference between x and y. The difference here will be the elements belong to the first set only. So I want the elements in x doesn't belong to y. This part, which is only pink, this is only x. So this interval from negative 3 to negative 1, and you know that we have to write the interval from left to right according to the ordering of the number on the number line. So negative 3 is first, then negative 1. Negative 1 here, closed, so I will write it open. Why I did that? Because the difference, I want this part only. Negative 1 belongs to y. I don't want y. Y here closed at negative 1, so negative 1 contains in y. So I don't want any number belongs to y. I want to write any number before -1. I will write -1, but open. The same here. Y difference x. I want the part contains only in y. Y is the first set, so I want the elements which belong to the first set only. Y, this part belongs to y, the blue one, from 3 to 5. Also, 3 here belongs to x. I don't want any number belongs to x, so I will write 3, but open 3. The last operation with the complement, which is all the real number except x. I will consider here that my universal set is the set of real number. If the universal set is the real number, so I will take all the numbers except x. If x, for example, is -3 and 3 and I want x dash, I will draw a number line for x. This is x for all the numbers from -3 to 3. So the rest of the whole real numbers, it will be x dash. All the numbers except this interval. So if I consider that the real number are from -infinity to infinity, these two parts will belongs to x dash. So I will write it as it is in two different intervals. So I will write the first one from -infinity to -3, and I will not take any number belongs to x. So if this number closed in x, it will be open in x dash. X and x dash are totally different than each other. This is no common elements between x and x dash. So if the number is closed in x, it will be open in x dash. And we will take the interval. I will say it once again. We will write the interval with the order of the numbering on the number line. So this interval is -infinity to 3. But the other one, it will be from 3 to infinity. I will put union. I want these two parts, so I will put union between them. Again, if I have y numbers from -3 to infinity, I will draw it again from -infinity to 3. This is y. I want y dash. Y dash, we said before, the rest of the real number, so it will be the rest of the number line. So if this part is y, the other part will be y dash. And if I want to write it as an interval, I will start from left to right, 3 to infinity. 3 here closed in y, it will be opened in the y dash. This is the complement. For example, I have here an example contains all what we said before. If x, the number from -infinity to 2, y is the numbers from -1 to 6, I want, using the number line, all the operations here. So I will draw again x, both intervals at the same number line. X from -infinity to open 2, this is x. And y from -1 to 6. Consider the ordering of number. Don't write -1 over there. -1, it will be here before 2, and 6 will be after 2. So this part is called y. Number 1, I want x union y. As we said before, the union is the two intervals together, or all the numbers in the two intervals from starting to the beginning. So it will be from -infinity to 6 as it is closed. Number 2, the intersection between x and y, or the common elements between x and y up and down here, have the same numbers from -1 to 2 as it is closed. -1, open 2. Number 3, x difference y. I will remove y. Imagine that we removed y, or I want the numbers only in pink. The numbers only belong to x. It will be this part till -1. So it will be negative infinity to negative 1, and we change negative 1 to open because it belongs to y, and I don't want any element belong to the other set. Number 4, y difference x, I want the elements which belong only to y. So I want the part here, the blue part, this part from 2 to 6, this part belong only to y. This part is common between x and y, so I want the part only in y. It will be the numbers from 2 to 6, and look here, 2 opened in x, it doesn't belong to x, so it will be closed in y. It belongs to y because it's between negative 1 and 6. Of course. Number 5, I want x dash. I will draw a separate number line for x from negative infinity to open 2. This is x. To be easier for me to find the rest of the line, or to find x dash, it will be the rest of the line from 2 to infinity. And of course, if 2 opened in x, it will be closed in x dash. Number 6, y dash. So I will do again the same, draw y and separate number line. This is y, so the rest of the line from negative infinity to infinity will be y dash. So y dash here will be written in 2 different intervals. One of them from negative infinity to negative 1 open, changed in y, and from 6 to infinity, putting union sign between them. Thank you, and this is our lesson and our operation in interval. I hope you enjoy it.